Welcome back everyone to part 2 of this series where we find the domain of a composite function. We left off with question B where we have to find the domain of G composed of f. We'll use the same strategy as before where I will take f and substitute it everywhere I see an x in my G function. So my brand new function will be G composed of f of x is equal to the square root of 5 minus, and since this is multi-termed, I'll place it in its own parentheses, negative 10 over x minus 4, all square rooted. What I want to do is find the restrictions within this function. And one of our restrictions is this fraction. This fraction, we have x minus 4 at the bottom. And in all fractions, the denominator cannot be 0. So I have to make sure that x minus 4 does not become 0. Solving for x, we get x cannot equal to 4. I just brought that over. So that's one of our restrictions. Another restriction is that this square root cannot have a value that's less than 0. So 5 minus negative 10 over x minus 4 must be greater or equal to 0. And I'll have to solve. Bringing the 5 over, I get negative 10 over x minus 4 has to be greater or equal to negative 5. Getting rid of this negative, if I divide both sides by negative 1, that goes away. But in an inequality like this, if you divide by negative 1, that becomes the opposite sign. And this is positive 5. So I have negative 10 over x minus 4. I need to solve for x, so I'll multiply both sides by what's in the denominator. That will get rid of the denominator, making it easier. Negative 10 less than or equal to 5x minus 20. I expanded. Bringing the negative 20 over gives me negative 10 plus 20 over 5 less than or equal to x. And all of that becomes 2 less than or equal to x. So we will represent these on a number line just as before. And in the middle is 0. That can be represented as a straight line where it cannot pass 4. So I'll put a hollow circle to the left and to the right. And this one, x must be less than 2. And it can be 2. So I'll put a solid circle that corresponds to 2 and everything to the left. So 100% where they are in common is part of the domain. So I'll write down negative infinity all the way to 2. It can reach 2, so I put these square brackets and parentheses around this one. Now, what about this part between 2 and 4? If we were to substitute a value between 2 and 4, let's say 3, into this equation, we would end up with a negative radicand, a negative inside part, and you can't square root a negative number. So nothing between 2 and 4 will work. However, if you were to substitute something greater than 4, let's say 5, into here, you will end up with a positive number. And because it's a positive number, you can square root it. So anything after 4 also works. So it's important that you do a test before you conclude. We will say that 4, it can't be 4, but it can be anything after 4, all the way to infinity. And it's the union between these two. And there you have it. Another example on how to find the domain of a composite function.